In this video, I'm going to discuss about 10 frequently asked technical questions in any analytics interview. So we'll start with the first question. The first question is, what are the different stages of the model building process? So the different stages of model building process are the following. You start with defining a problem statement, and then you collect your data and you consolidate your data and come up with the final data set, and then you start cleaning your data set because most of the times your data will not be clean enough. Then you select your variables, which are the variables to be used in the final model, and then you start with variable exploration. We call it exploratory data analysis, which is nothing but exploring your data and variables and come up with the best set of data and best set of variables, which will ensure that the model is good enough for use. Then you develop your model, and then you validate your model. So once the model is developed, you ensure that the model is going to work in the new data. So you do then you do the out of sample validation and the out of time validation. Then we do model implementation. So once the model is finalized from the model validation step, we implement the model on the web platform or on a desktop platform. Then in the process we start from the very beginning itself we would have started the model documentation. So we finalize the model documentation once the model is implemented, and then we monitor the model on a regular basis. There will be slight deviation in the modeling steps depending on the kind of industry you're working with, or depending on the company. So there will be some company specific steps. There are certain steps which are omitted, like there will be literature review, wherein you will be discussing, or you will be finalizing the technique to be used. So we call that literature review. That's also an additional step which is performed. There will be several other steps related to data checking and validation. You will come across steps like regulatory data checking, and then there will be auditing as well, external audit by the audit organization like PwC or Deloitte or Ernst & Young. So this is the way the models are developed. The next question is, what are the different variable detection techniques that we know of? Well, the most popular one in the banking and financial industry, also in the retail industry, is using variables, or finalizing variables using the information value criteria. So the information value criteria is used to find out the predictive power of variables. So the one which are having good predictive powers are preferred and that is used for the model. Then we also use clustering. Clustering is used to find out whether two variables are very highly correlated or highly uncorrelated. So we ensure that we select the independent variables which are highly uncorrelated among themselves. So we select a couple of variables from the cluster. So you will have a cluster of variables. So we just take the best one or two variables from the particular clusters, because in a particular cluster most of the variables will be very similar or very highly correlated. So we'll just pick one or two out of these clusters. Principal component is also similar technique, which is very similar to clustering, except some fundamental or computational difference. Principal components are used to reduce variables. So we come up with composite variables which are used instead of the raw variables or the original variables. So principal components are very useful visualizing the data, and also coming up with a very smaller set of variables. But these are not very useful when the purpose of your modeling is to find out the relationship between variables. Principal components greatly helps when it's all about prediction, but doesn't quite help, or it doesn't help much when the modeling objective is to find out the relationship, or finding out the marginal impact on your dependent variable. Then comes factor analysis. Factor analysis is related to a set of modeling technique known as the structural equation modeling, which finds out the relationship between different factors. So factor analysis is very similar to principal component analysis, except the fact that factor analysis is used only when you have causal hypothesis to be tested. Otherwise, it's not very useful. You can always go ahead with principal component. And factor analysis is also used for reduction of variables. You come up with a very smaller set of factors and come up with the finally build a model. The next question is, so what do you mean by exploratory data analysis? We talked about in the first question. So if somebody asks this, what exactly do you do in an exploratory data analysis? This is often a question asked because most of the times we concentrate a lot on the simpler techniques before going ahead to the more complicated and sophisticated techniques. So the exploratory data analysis, in short known as EDA, involves the following. We start with the basic descriptive statistics like mean, median, mode, minimum, maximum, number of missing values, and univariate analysis like your quantile plot, your quantile distribution, and then the finding out of your percentile distribution and so on, extreme values and so on. And then you visualize your data using graphs and plots, very useful to find out outliers, extreme values, and then find out a basic pattern in your data set. And then use more sophisticated univariate and multivariate techniques. So multivariate technique would be your correlation, principal component analysis, clustering. So these are the techniques used to find out relationship among the variables, which variables are highly correlated among themselves, which variables are very similar. So we can club them together and come up with a composite variable. So all these decisions are taken before even the model building is started. So that comes under the exploratory data analysis. More statistical plots like histograms, and then you use the quantile plot, the quantile plot for the checking of normality. Some models demands normality of your data, normality of your variables. The variable has to be distributed normally. So for normal distribution checking, you use quantile plot, and then the extreme value detection, which is also extremely important because a lot of time these extreme values create problem, and this has to be removed from the data set before even you can go ahead with the. The next question is, what are linear models, and how are they different from the non-linear models? A model is called linear when it is linear in parameter. Now understand this particular statement, the linear in parameter. So we cannot say a model to be nonlinear if it is nonlinear in variables. So it has to be nonlinear in parameters. So a linear model is always linear in parameter, and I'll give an example which will be more clear. And the function which relates your dependent variables with your parameters has to be linear functions. So let's take an example. So y equal to a plus b x, where x is your independent variable, y is your dependent variable, a and b are your parameters. Now this is a linear model because both a and b are they are in linear forms. But if you have like a square or b square or square root of a, something like that, or logarithm of b, then the model is going to be a non-linear model. So an example of non-linear model is like this, where y is equal to a plus b square x. So this is a non-linear model. But remember that y equal to a plus b, y equal to a plus b x square is not a linear model. Y equal to a plus b x square is not a non-linear model. This is a linear model because it's linear in parameters. So a and b are parameters which are linear, so it's still linear model. So non-linear model usually involves estimate terms like product of two parameters or square of one of the parameters. The next question is, what is the difference between a parametric model and a non-parametric model? Well, the main difference is the data which is used is assumed to follow some theoretical distribution in parametric models, like normal distribution, like binomial distribution, and so on. On the other hand, the non-parametric model do not assume any theoretical distribution. So what do you mean by theoretical distribution? Well, the theoretical distributions are the one that we might have studied in our textbooks, like your normal distributions, binomial distribution. So when you're doing a multiple regression, we generally assume that the error is normally distributed, whereas in logistic regression, there is an assumption of binomial distribution, right? So these two models, your multiple regression model and the logistic regression models, come under the parametric model. But there are models where there is no such assumption. So the algorithm itself finds out what exactly the actual distribution of the data from the data without assuming beforehand. So those models are known as the non-parametric model. So your example of parametric models are normal regression and the binomial regression, and the example of non-parametric models are the smoothing models, mostly the kernel smoothing model or a scatter plot smoothing model. So these models are the non-parametric models. The next question is, what is the main difference between a correlation and a regression? Well, the correlation is a two-way phenomenon. That means if x and y are two variables, so we try to see how x is related to y and y is related to x. So it's a two-way phenomenon. It talks about the strength of relationship between two variables from both sides, from x to y and from y to x. Whereas regression is always a one-way phenomenon. That means you always want to find out what's the impact of x on y. You don't do it the other way around, right? What's the impact of y on x? That's usually not something that we see, but there are models where we actually see the both way effects. But normally in most regressions, the impact or the relations will be one way all the time. The second difference is that a correlation doesn't give marginal impact. That means if we know that two variables are correlated and we know there is the correlation between these two variables, we cannot say if we increase one of these variables, say x, by 1 unit, what will be the corresponding impact on y. So that's not possible from the correlation. But in regression, you can always find out the marginal impact. That means in regression, for example, if this is the regression model, y equal to beta naught plus b1 beta 1 x, if we say that x increases by 1 unit, you can say what the corresponding increase in y is nothing but your delta y by delta x, right? So that's your marginal impact. Next question is, how is correlation different from causation? This is a philosophical question, little controversial, but one of the answer that you can give, which may not be 100% correct, because it's slightly confusing, and also not a very clear cut question, but a lot of people actually ask these questions, so I'm talking about it. So causal relationship is established when the relationship is very intuitive and it adheres to some accepted hypothesis. But correlation, which can be found between any two variables which are not at all correlated. So causation always has to be very intuitive, or something that you can always expect. But sometimes the relationship between two variables could be spurious in nature. That means they are correlated, but in general you won't find you know any relationship in the real world. So that's exactly is the difference between a correlation and causation. The next question is, how do you validate the input data sets used in the model building? This is often a question people struggle to answer, because in a lot of in a number of companies or number of projects I have seen, data validation is not a step. If you remember, in the first question, we did not talk about the data validation. We only talked about the model validation. But data validation is also an important step in the model building process. Many a times we get data from different departments, mostly the IT departments. Okay, and IT usually don't have very good knowledge of if the data quality is actually good enough for model building. Now, when we talk about data quality, there are different types of data quality which we need to ensure. So there are some IT specific data quality checks like format and so on. So these things are taken care of by the IT people. But there are some model specific data quality checks which normally ignored by the IT people. For example, one of the check is range check, right? You want your data to be falling under two particular limits. Say for example, one of your data set is a probability value, right? So probability always has to be between 0 and 1, right? It cannot be a negative number, and it always has to be between 0 and 1. Now well, the IT may not check this particular variable. So the modeling tips should ensure that another round of validation checks or data quality checks should be made before starting with any model development exercises. So that's important. So ensure that you double check your data source, whether the source itself is correct or is a reliable source. Otherwise it will be like garbage in and garbage out. So model results will be erroneous. Then apply common sense. So apply common sense sometimes. For example, the age of customers cannot be 200, right? So that's wrong data. So that you also ensure. And then compare data with previous year. The team which developed your model in the previous year must have done some validation checks. So always good to compare your data with the previous year data. But it doesn't mean that if it matches with the previous year data, it's good. There are it could have happened that in last year your team did not perform validation check properly, and there were mistakes. So that could be carried forward to the next year. So ensure that that is well validated with your previous teams. And then do some very basic data exploration and visualization. A lot of these data issues or quality issues get caught when you actually visualize your data. So good to plot each and every variable so that you will find out some anomalies. The next question is, why is too many missing values in the input dataset a problem, and how do you treat missing values? This is an important question. In most technical interviews, you will face this question. Well, the missing values actually create problems for the algorithm to converge. A lot of time, if your data set is having too many missing values, it takes a lot of time to converge firstly, and also many a times your algorithm will not converge. That means if you're running a logistic regression or a discriminant analysis, most likely with a large number of missing data, it's not going to converge properly. There are techniques which takes care of missing values automatically, but these techniques are mostly used for prediction purpose. But econometrics models, mostly which are used for finding out relationship between variables, will have problems with missing data. So that should be corrected. So missing values are replaced by mean values of series and time series data. So replacing missing values in time series data is a lot more easier than other form of data like cross-section data. In time series data, if like one of your variable is missing, you just take the previous values, because we generally take the in univariate time series data. You'll always find the data for a particular event or a particular entity. So that data gets continued for a period of time, so you can use the previous period if that's for a particular period you don't have the data, or else you can also take the mean of the entire series and do the imputation. One of the industry very well-known technique used in industry is the weight of evidence, or in short we call it as WI. So WI method of transforming your variables into WI variables ensures that your missing values are taken care of. So each continuous variables, even the categorical variables, can be converted into the weight of evidence variables. So weight of evidence variables generally make sure that your continuous data is grouped into categorical variables, and the missing data is considered as one category. Okay, so you can check the videos on weight of evidence. There is a playlist in my channel. You can see these videos, watch this video, and you will understand how weight of evidence can be used to treat missing values and outliers. The next question is, why is presence of outliers in the model a problem? Well, if you encounter a lot of outliers in your data, now what is an outlier in a data is actually difficult to answer firstly. So if you really think that there are a number of extreme values in your data set which are definitely different than most of other observations or most normal observations, then you call this these values as outliers. And not all the times though, because you have to be very careful. So this definition is slightly complicated and confusing. It's not that easy to find out outliers in your data set. Sometimes some data may look like extreme values, but removing this data will really impact the predictive ability of your model. So do a good check of whether your data actually has outliers and remove them. If you don't remove them, then you will find out that your standard error of the parameters will be a lot more than expected, and then your estimates are going to be unreliable. You cannot interpret your estimates. So that's the problem. So you should ensure that the outliers are removed. Thank you, and you can subscribe to this channel for more videos, and I will be uploading more question and answers sessions in my following videos.